All right, good afternoon. My name is Lindsay Sutherland Baharia. I'm the Customer Success Manager at GeoNexus. Thank you so much for joining us for today's webinar, How the City of Clearwater Shifted from a Custom to a Productized Approach for Data Integration. Before we get started, I have a few housekeeping items. First, if you have any questions throughout the presentation, please use the Q&A feature to submit your questions, as you can see here. We'll save a few minutes at the end of the presentation to answer these questions, and if we're not able to get to all of the questions, we'll follow up after the webinar. Also, as a reminder, this webinar is being recorded and you will be sent a copy of the recording after the webinar. On the call, in addition to me today, we have Jeremy Williams, IT Manager for the City of Clearwater. Thank you so much for joining us today, Jeremy.
My pleasure. Thank you for having me.
So here's our agenda for today's presentation. We're going to start with a brief overview of GeoNexus and the integration platform to give you some context. And then we'll turn it over to Jeremy at the City of Clearwater to share their story. And finally, we'll conclude with a brief Q&A. So a little bit on GeoNexus. We were founded 10 years ago. We currently have 20 employees and are growing. We have over 50 customers worldwide, with a majority in the United States and a growing presence in the UAE and Australia. And the principals at our company individually have over 25 years of experience in the data integration space, which leads into our mission and what we're all about here at GeoNexus. Our mission here at GeoNexus is to provide our customers with a proven platform for system integration that is fully supported and ensures the integrity of their enterprise data. This is our sole focus, and we deliver this through our integration platform. Our platform achieves our mission by focusing on these three areas: data integration, application integration, and data quality. So starting off with data integration, our platform allows you to synchronize large volumes of data using a full compare approach. So we're actually extracting this information and doing a cell-by-cell comparison to determine if there are any changes, edits, or updates to ensure integrity across your enterprise systems. Then there's application integration, which is connecting applications in near real time to streamline workflows and events to support work and asset management processes. This supports the end users with information that they need to do their jobs. So for example, they may require a map of information about their infrastructure, their assets, and work orders, and they want to pull in data from their asset management system or customer information system. Application integration enables this process, and Jeremy is going to touch on this a little bit in his presentation with how they're using this functionality to view information from their asset management system within a map context. So finally, we get to data quality. Our platform provides advanced reporting to increase the trust and reliability of shared enterprise data. Every time the synchronization is run, there's a PDF report sent out detailing all the discrepancies, duplicates, orphans, errors, and more. This provides an understanding and insight of your enterprise data quality to increase the trust and reliability throughout the organization. So this is what our platform provides: data integration, application integration, and data quality. This is all supported on a foundation of connectors, which you can see listed here. As our company evolves, we are adding more connectors into the mix, including Infor, and we're also embracing partnerships with system integrators and customers who want to leverage our technology for specific use cases by giving them the tools to build their own solution through our software development kit or SDK. Finally, we're working to support generic integrations through our RDBMS connector, which gives us the ability to connect to any relational database system. So this platform is all about connecting enterprise systems and ensuring the integrity of data being passed amongst them. So today, Jeremy is going to be highlighting part of our platform called GeoWorks Sync. So I wanted to give you an overview of GeoWorks Sync before I hand it off to him. So GeoWorks Sync is our data integration product that allows you to connect disparate systems through an easy to use and configure interface. Jeremy will focus on some GIS to GIS integration, which we show in this slide. But like I said on the slide before, this product can connect to a multitude of systems through loosely coupled no-code integration. So one of the other aspects of GeoWorks Sync that I want to point out is that relates to data quality is the reporting capabilities. Each time GeoWorks Sync runs, a report is emailed to designated recipients in PDF and XML format. This report outlines exactly what happened during the sync run, including any discrepancies. This allows users to track the integrity of their data and take further action based on the results. In fact, we have some customers who use GeoWorks Sync solely for this purpose, to review data discrepancies and plan further action based on the results of that report. So with that brief overview, I want to go ahead and hand it off to Jeremy, the IT manager from the City of Clearwater. He and his team have been customers of GeoNexus for the past 5 years and have been able to take advantage of some of the extended capabilities that the platform has to offer. So with that, take it away, Jeremy.
Thank you for that, Lindsay. I appreciate it. So today I wanted to talk basically about the integrations that where we were and where we are now using the GeoNexus platform. I will touch on some other technologies that are outside of the sync, the GeoNexus sync platform, and I will have a few slides that will highlight that. So first off, what is and who is the City of Clearwater and what do we do? We're located in a county known as Pinellas County in Florida. Pinellas County is actually the most densely populated county in Florida. We are surrounded on all sides by other counties that are also densely populated, and we make up the greater Tampa Bay area. 118,000 residents in the City of Clearwater, but of course you would never know if you're leaving Clearwater unless you're really paying attention to the municipal signs as you're going from municipal boundaries. We manage multiple utilities that basically runs the gamut. We have a natural gas utility as well that actually goes outside of our normal 35 square mile service area. It covers something more like 300 square miles. We also have roadways and traffic infrastructure as well. Now, as far as where were we and why did we even contact GeoNexus? That's kind of everybody's kind of genesis story. We embarked on an enterprise asset management system in about 2003. And it was known as something else. Right now, is known as Oracle Work and Asset Management. It's a pretty typical enterprise asset system, or EAM. We had a focus on utilities, and the way that WAM works is that it uses a plant model, and those plants can be broken up really depending on however you want the hierarchy built. But we ended up building it as like plant 1 is utilities, plant 2 is solid waste, plant 3 is whatever, the gas department, for instance. We have 7 plants that we operate, and that's how we split up the hierarchy of our assets. Now this is kind of reflected in the GIS as well, but also not. Why I point that out is that the structure of your asset management system does not dictate how the GeoNexus platform works. So they can be, as Lindsay said, they can be very much different, but you can integrate the data between the two. And that's really what I'll talk about today and the powerful aspects of what this platform provides. We had, have and had multiple integrations with other enterprise systems. We consider enterprise systems to touch multiple departments. That's kind of how we use the word enterprise. So it's a more all-encompassing citywide application, if you will. GIS, our customer information system, or CIS, or UMS in some cases, the payroll system, and other infrastructure inspection software. Now, with GIS integration, typically you have a lot of different types of data in your GIS. You have, it's very fundamentals, lines, points, polygons. Well, that data represents something on Earth that generally is also important and may also be linked to a system like an asset management system. So in this screenshot here, I have an image of kind of a section of roadway with other infrastructure that includes potable water, reclaimed water, sanitary systems, hydrants, a little bit of everything, kind of a typical city GIS. Well, this is a great way to visualize the data because it's in GIS and it's right there. You can see the polygon for the parcel fabric under it. You can see the location of the assets. You can see the proximity. It basically gives you a good reference of what am I looking at. But of course, if you're looking at this doesn't tell you anything about the age or anything that, the service, anything that the asset management system may contain. So where did we come from? And one of the reasons why we, contacted GeoNexus in the first place. Well, this is a snapshot of the past interface that we had with GIS and the asset management system. Now, we were fortunate enough to have staff that could write interfaces between systems. And so that's what we did. We wrote, in this case, it was 6,000 lines of code to translate data between one system and the other. So in this case, this is our OM system, or our Oracle Work and Asset Management System, talking to our GIS system. And in this example, it's saying, if I can find something that's similar, let me update, its asset management number, or what we call a Synergen ID, which we now call WAM ID. Now, the beauty of this is that that field that we're updating now in the new platform could be literally named anything. I could have named that field Jeremy, and it doesn't matter because of how flexible the environment is. So I wanted to point that out because instead of having to go through all of the lines of code, now all I have to do is look at a GUI. And this is something that I don't need to, necessarily hire staff that know PL SQL. I don't necessarily need them to understand data integrations because the GUI itself really kind of walks you through the basics and the fundamentals of what am I connecting, how am I connecting it, and how do you want that connection to look? So that includes things like transformations. A lot of the time, the data does not have the same field from one to the other. Well, within the GUI itself, you can provide field A and field B. You can tell it's the same thing. It'll even truncate it if the fields aren't the same length. You can update it one direction. You can update it two directions. You can update different fields depending on what the situations are via what's called in the system a where clause, which is a very common GIS term. It's on the display attributes in a GIS. You may input a where clause. Well, GeoWorks Sync works very similar to that, where you input a where clause and you can tell it to ignore things. You can tell only to update these things. It's pretty powerful. And what's even better is you don't have to go through 6,000 lines of code to fix a simple error or a simple addition or a simple removal from your GIS or asset management system. You can just simply pick the data set and either add one or remove it or update it. So this really helped us with development lifecycle. That's something that really, in the past, we were putting these systems in, highly complicated systems, and then we were kind of ignoring them and just letting them run because we had other priorities and limited staff availability. So once we had this PL SQL in, we really needed that thing to run forever. And, you know, it did. It ran for many, many years, tens of years. And it was okay. It did its job, but it started getting kludgy anytime we needed to do an upgrade, for instance. You know, we would put new server architecture in, for instance. Well, now you have to kind of rewrite everything. And yeah, you could probably just do, in some cases, a find replace in that custom code. But wouldn't it be easier if you could just do it through a GUI? And so that's really when we started looking at GeoNexus, because we said we need to upgrade. The Esri versions are changing rapidly now. They didn't used to change as often as they do. They change quite often now. We needed something that was up to date, ready to go, and really the GUI interface was really what we were looking for. We also needed, obviously, something to be reliable. We needed it not to take forever, and we needed it to be malleable in the sense that we could change basically on the fly, on our whim. Anytime we had users, especially on our GIS side, add new features or new fields because they wanted to track something a little bit differently, well, that was a real pain before. Now it's really no big deal. And we talked about reports a couple minutes ago. Lindsay brought that up. The reports were essentially non-existent in the past. Now there is a PDF report. We have it sync an email also with kind of the results, you know, how many errors, if there were any, you know, what you need to pay attention to. And that's really how we leverage the reports. We really use the email kind of the initial as a flag to tell us, do we need to pay attention to this or no? And then if we do, we just go to the report in question and it outlines specifically what the issue is. It also gives you an idea of how long is it taking, or how long did it take? How many did you do? In this case, this is a synchronization report, literally a data server to server, and we're asking it to do 104,000 records. And then if there are any errors involved with that. So the reporting is fantastic. Now this is a screenshot from, not from the Sync product, but from the GeoWorks Office product. So this is kind of part of that. If you synchronize the data, well, now you can visualize the data. And so this is really where this comes into play. Using this, we are able to tie the GIS data and the WAM data directly to each other. And you can do this a myriad of ways. One of the ways that we do it is that we populate, we have GIS data and we have WAM data. It's referenced, it's identified as a commonality. And that common bond is an ID. And I mentioned the WAM ID or the Synergen ID earlier. And I also mentioned that you could call it whatever, you could call it Jeremy if you want. Well, in that case, we are creating that symbiotic bond between the OM, in our case, and the GIS. And now we're able to visualize the data. And in this visualization, the user, through another GUI, can click through the system. But I wanted to include this GeoWorks Office because I think this, in our particular case, really makes this whole environment powerful. And in the current state, we have, this is basically what a snapshot of the work orders from the asset management system are. And as you can see, they are linked to, they are geographically spaced, and they are on the assets themselves. So all the little dots are work orders, specifically tasks in our case, and they are tied to an asset because you work against assets, right? Well, this really provided a great way to visualize a lot of redundant work that was being done. You can see in this snapshot, which I actually borrowed, it's not one of ours because I couldn't find a really good example, but this is an example of a pipe collapse. And this pipe collapse is, you know, usually you can see it just in the road. The road kind of undulates or it has a little like a bow in it or something. Well, if we had written, in this particular case, if we had written 3 work orders against that same thing and we hadn't identified, within like 12 months, and we hadn't identified that as a pipe collapse, whoops, right? We should have probably fixed that pipe collapse first instead of fixed the road 3 times. So this is just a really cool way to kind of visualize the data. And I like to include that in the conversation. Now, where did we come from? That really is probably familiar for a lot of us. ArcIMS was a great tool, but goes back to that hugely custom environment. Well, that's exactly what's in the foreground there. The old and the new. This is just a better way to visualize the data. It's much faster. It's much more reliable. And it's basically with the times. It works. Now, I will say that IMS viewer, that was this last snapshot that I got of it before we retired that server 5 or 6 years ago. But we were still using it. But it was really becoming a headache, and a lot of time was consumed in keeping it maintained. So I want to talk about what we're doing with GIS and how we're really leveraging the sync. So in an ArcGIS environment, you have typically an edit database at the very least. And I'm using terminology that GeoNexus uses, and it may be also terminology that you use, and if it does, then good for you. The edit database is where your edits are going. So this is the terminology that I'll use. The other side of that is the published database. So theoretically, the published database is data you don't edit. Your GIS editors are not, doing anything in that. It's purely, as the word publish kind of symbolizes, it's purely the data that's used for visualization. The edit, however, is the data that's getting, that's where the GIS editors or even the analysts, they're doing all their heavy lifting and adding data and removing data, updating data, and all of that. All those CRUD operations are happening there. Well, in a traditional GIS, as I mentioned, you typically have edit and publish, and you usually have a one-way feed. And this is what we're doing through Python scripts. We were saying, okay, from edit, go update, publish, and all of our viewers and all of that good stuff was connecting to publish. Publish is typically a different datum. In our case, we use WGS84 just so we can leverage things like Bing Maps and Google Maps and whatever, just more off-the-shelf web stuff without having to worry about too much of our own visualization tools. So we publish everything in WGS84, the web mercator. Well, our edit data is not that, it's NAD83. So that update had to go take the database, it had to transform the database into a different datum. In some cases, our published database, the fields needed to be a little realigned or even calculated differently or whatever it was. Well, we were doing all of that in those Python scripts. This took forever to run. It was really heavy, a lot of disk I/O operation. Outside of the initial database extract, it was very time consuming. So yes, it was an upgrade over what we were doing, but it was still custom through Python. So step one, as soon as we got GeoNexus Sync installed, what did we do? We created a bidirectional relationship between that edit and publish database. And guess what? It updated a whole bunch of stuff that we totally forgot about in our custom Python. So not only did it kind of catch us up in a way, but it created a bidirectional relationship. And it runs way faster. So that's kind of a typical experience. Well, now you can kind of put this thing on steroids, and this is a snapshot, probably gives you a look into where we were a couple years ago. We're not all that different from right now from this image, but what we're doing here is we have a production GIS server. We have 2 databases with 2 different datums. Now we also externally host data, and what I mean is I externally publish data to a server on the DMZ to keep that data safe. I don't want a production GIS out past those firewall protections. So what we do is we end up having an edit and publish database there, and I'll go into why that is, because that might seem redundant to a couple of you. Then we obviously have a test, or even a DR is how you could view test as in some cases. Well, that external GIS server, that actually hosts another and different set of edit data. And the reason why I bring that up is, especially with the advent of things like ArcGIS Collector, and I'm an Esri customer, so I'm going to use Esri terms here. ArcGIS Collector is fantastic as far as going and doing field collections, and even Survey 123, and they have a couple other platforms that do kind of similar things. Well, ArcGIS Collector, well, that needs a database and a connection to something to go and edit that data, because that's literally what you're doing. You're editing data from like an iPad or something like that, right? Well, I'm not about to expose my production GIS server to the internet for that use. So what do? We have an edit database connected to our external GIS server. So that edit data is different than the edit data on production. It's similar in some cases. Yeah, it might have some similarities, but in a lot of cases it has different things. Now the published data, however, that could or may not, depending on how you use it, that may be a mirror copy of your edit data. So we basically have an internal viewer and an external viewer, or viewers, I should say. Those internal viewers have more sensitive data. Internal means that only City of Clearwater employees can access that data. Now on the external, those are my public viewers, things like zoning, future land use, or if they've been deemed able to get it, I also password protect some viewers so that we can have consultants access what we deem as sensitive data. And then obviously test has its edit and publish, and that for the most part mirrors production, with some exceptions if we actually have something in development. Now all of that can then be translated to ArcGIS Online, and that's AGO over there. That's kind of, and I just symbolize that as kind of just a general bucket, because you can really have that organized in 100 different ways. So the point being is we have two different datums, two different, well, in this case, 4 different database servers. One happens to be hosted on ArcGIS Online. We have a few different databases. They all kind of contain similar data, but different. And again, depending on your need, you may even have in this diagram, I mentioned DR a minute ago, you could actually have a DR site being completely populated using GIS Sync or GeoNexus Sync, if you so chose. And we are using it to that degree. We're using it to make sure we don't lose data. And I don't have the DR environment here in this picture, but I just wanted to kind of point out that it's not just GIS data, it's also your asset management data. It can also be your disaster recovery plan, or at least a portion of your DR plan. Scheduling. And this is really pretty basic. You can schedule the sync jobs multiple different ways. So based on that diagram, you may have already deducted that we're probably using sync on a few different servers, and we are. We're using that because the jobs that aren't related to each other, we can end up running multiple sync processes at different times or same time on different servers, leveraging different equipment. So basically, we've scaled it. That's the picture I'm trying to paint for you, is it's scalable. So you can either leverage a task manager, you can write a batch file. They're basically little INI files that are created from sync, and you can run it through a command line. So that's a great way to put it into task manager, put it into SQL agent, or any agent for that matter, to run those processes. So in conclusion, the sync product helps us keep the published data up to date. We do multiple transformations and projection switches. We can establish bidirectional relationships with data, different data sources and different data types. You can schedule it as needed, and you can run it on demand. What's also cool, and I didn't go into this, is you can run everything in what's called a preview mode. So if you are really just kind of hypothetically building something, you can see what it really means on the back end through the preview, because the report that kicks out looks like a real life report, but it tells you what it's going to change before you hit that go button on live data and accidentally wipe out your live data. I'm just kidding. You're not going to do that. But you can literally preview what it's going to do first. So there's even built-in safety mechanisms for you to make sure that you don't do something silly. And that's really it.
Thank you so much, Jeremy. That was great. We really appreciate your partnership, and we've really enjoyed working with you and your team. So thank you. I know we went over a little bit today, so we're not going to have time for questions, but for those of you that did ask questions, we will follow up after the webinar. So thank you so much for joining us, and thanks again, Jeremy.
Absolutely. Thank you for having me.